So the first thing that we're going to do is just like we saw last time, we saw we could write an equation as a matrix equation. Let's say we had the equation, let me just find a good one here. 2x minus 5y equals 15. 3x minus 6y is 36. So we're going to go ahead, like I said, and we're going to put this into a matrix equation first. Okay, a matrix equation. So that would look like such. 2, negative 5, 3, negative 6, xy equals 1536. Does everybody remember the matrix equation from last time? It's part of your homework as well. Any questions there? Now, I was trying to show you last time that I could do this via my calculator really quickly. Okay, do I ever divide? Because notice I want matrix A, xy right here by themselves, don't I? So I want to get rid of this matrix. Okay, and how I get rid of that matrix is I can't divide matrices. There's no such thing as dividing matrices. What I have to do is times by its identity, or I want to make it an identity matrix, which makes it, how I get that is an inverse. Okay, let me hear you just talk about what that means first. Multiplication identity. When I just do regular multiplication, okay, 1 is my multiplication identity. Meaning, if I go 3 times 1, I remain 3, correct? So, how do I ever get the multiplication identity? If I have this number 3, what do I times by to get to 1? I times by its reciprocal, which is another name for its inverse in this case. When you multiply inverses, you will always get the identity, the multiplication identity, correct? Everybody good with that? What is the additive identity? Anybody know? 3 plus what gives me 3? So 0 is our additive identity, correct? Would you guys agree with that? Yes, no, maybe so. Okay. So when I do so, once again, when I add inverses together, because these would be inverses when I'm talking about addition, 3 and negative 3 would get me to my additive identity, correct? All right. So now when we're talking about matrices, for a matrix to have an identity, it must be squared. Such as 1 by 1, 2 by 2, 3 by 3, and so on. Does that make sense? You cannot have an identity if it is not a square when we're talking about the multiplicative. Okay, so for a 1 by 1, here's your multiplicative identity. It's just 1. If it was a 2 by 2, it looks like that. If I have a 3 by 3, it looks like that. So basically, what does that look like? Reduced row echelon form, doesn't it? Okay, but once again, it can only be on square matrices. Okay, so if I was going back here, okay, back to this problem, what I want to do is I want to multiply this matrix on this side by its identity. it's not its identity, by its inverse, so that when I multiply the inverses, they always become the identity. Like, isn't that how we get rid of timesing by 3 is we divide by 3 or times by a third so that we get a 1 times x, right? Does that make sense to everybody? Because we want this matrix to vanish, and how it vanishes is timesing it by its inverse. Okay, so what we're going to do is I'm going to show you 2 ways. Okay, for a 2 by 2, there's a really simple way, but on a 3 by 3, there is not. So I'm going to show you just how we would do that. Once again, my matrix that I had there was 2, -5, 3, 6. And what I do is I attach it to my identity matrix. Okay, and what I'm going to do is perform reduce row echelon form. Okay, and then on the right side, when I am done, when I have switched it from the left, see how the right side right now is the identity, right? Does everybody see that? When I go ahead and do reduce row echelon form, the left side will look like the identity, and I'll have a matrix on the right side. That right side matrix will be its inverse. Okay, so what's our first goal? Well, we want this 2 to become a what? Yes, sir. Was he a -6? He was. Thank you so much. That would change a lot. Appreciate it. Okay, so the first thing, I want this 2 to become a what? A 1. How do I make things a 1? I divide it by that number, correct? So here's what I would have now. I would have 1, -5 halves, dot, 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 1/2, and 0. Now, to be honest with you guys, you're going to be playing with fractions today, just for the fact that a lot of the identities have fractions within them. Okay? Now, this is a way that works every time. I'm going to show you a shortcut that only works on a 2 by 2. But if you had a 3 by 3 or a 4 by 4 or anything larger, for you to find the inverse, you would have to attach to its identity. Okay? There's only a trick on a 2 by 2. So far we got our 0. I mean our 1, right? What do we want with that 3 right there? We want him to be a 0, don't we? Does everybody agree with me on that? So I'm going to times row 1 by what? By -3, so that becomes -3. Positive 15 halves, -3 halves, and 0. So I go ahead and keep this number. So 1, -5 halves, 1/2, and 0. What's -3 plus 3? 0. 15 halves minus 6. 6, by the way, is -12 halves. Correct? Getting a common denominator. Would you guys agree with me there? 15 halves minus 12 halves is 3 halves. -3 halves plus 0 is -3 halves. 0 plus 1 is 1. Is there any questions so far on how I have this result? Pretty easy so far. Stuff we've already learned, right? Okay. So now where that 3 halves is, I want him to become a 1. So I go ahead and divide by 3 halves or times by 2/3, whatever you want to do, correct? So I have 1, -5 halves, 1/2, 0. Then I get 0. 3 halves divided by 3 halves, or 3 halves times 2/3 is 1. This is -1. This is 2/3. Okay, what's our last step? Where that -5 halves is, we want him to be a 0, don't we? So I use the bottom row, row 2, and I'm going to go ahead and multiply that by 5 halves. Is everybody okay with 5 halves there? So that'd be 0, 5 halves, negative 5 halves. 5 halves times 2/3 is negative 5/3. Any questions so far? Yes, no, maybe, yes, ma'am. Okay, so right here I divided everything by 3 halves, right? And 1 divided by 3 halves, or 1 times 2/3. Does that make sense, Rach? Does everybody understand? That's a good question. Okay, so here we go. 1 plus 0 is 1. Negative 5 halves plus 5 halves is 0. 1 half minus 5 halves is negative 4 halves, but negative 4 halves is negative 2. 0 minus 5/3 is negative 5/3. And then notice I have 0, 1, negative 1, and 2/3. You see how the left is now the identity matrix, right? I have made it into the identity matrix. So therefore, if we went back, give me 1 second, I'm going to go back. I'll let you guys catch up really quick, actually. Yes, sir. Because it was 0 plus 5/3, negative 5/3. Because I had to times this row by, oh, it should be positive, huh? Yep, you're right, positive 5/3. Thank you. Thank you for my mistake. And once again, that little minus can do a whole lot of damage, couldn't it? And so those are the things. That's the hardest part about this stuff is if you miss a minus, it just goes squampy. All right, everybody good? So we're going to call this matrix right here. I got to go figure out what I called him in the original. I'm going to call this matrix A, this matrix B, and this matrix C. Okay? So what I want to do, ladies and gentlemen, is I want to get rid of matrix A. For me to get rid of matrix A, I times by A's inverse. Who was A's inverse? What was those numbers that I just got from you that we had on the right side? Can somebody read them to me, please? Negative 2, 5/3, negative 1, and 2/3. Okay. That one kind of looks horrible up there. Okay, but can I just multiply a matrix on one side of an equation? What I do to one side, what do I have to do? Multiply to the other. Now, it's so important that you always do it in front. Because once again, do you see how I did it in front of matrix A over here? Is multiplication with matrices commutative? No. So therefore, the way I do it on one side, I must do it on the other. Okay? So what's going to be left here is just the identity, which is great. But what I will have is just xy, which is what I want. You guys agree with that? Because that's what we're looking for, right? We're solving. So what I'm doing, though, is that side is A's inverse, which is negative 2, 5/3, negative 1, and 2/3. And I'm going to multiply, that's A's inverse, by matrix C, which is 1536. Is everything in its right spot? You good now? All right, here we go. Negative 2 times 15. What does that become? Say again. Negative 30. Good. 5/3 times 36 is 60. If anybody wants to check it out, pretty sure that's what it is. Here, I'll even show you right here. 5 divided by 3 times that by 36 is 60. Everybody good with me on that? What do I do to those two numbers? I add them, don't I? And I get 30. Now, that was first row, first column. Now I'm going to do second row, first column. So I have negative 1 times 15 is negative 15. 2/3 of 36 is 24. Negative 15 plus 24 is 9. So what I know now is that x, y, matrix xy, equals 30 and 9. So what do we know? I know what x is, and I know what y is. Okay, that was just another way to solve a system of equations. Now with a 2x2, did that really feel like it was a lot easier than what we've already done in the past? No, I'd rather still just do elimination and bust that out, right? But once again, if we see these ideas, then we can do them for larger identities where it might not be as easy to go ahead. You just do reduced row echelon form and go for it. In most cases, they only make you do 3x3s by a hand, and anything larger, in all my math that I've ever done with it, if it's anything larger than a 3x3, they allow you to use a calculator to find its inverse. So I sure the hell hope they don't put one on your test, because you're not allowed to use those calculators, right? But I can't guarantee it, but that's the idea. So the key idea is what we're doing today is using these identities to find the inverse matrix to solve equations. Okay, now as I told you, there is another quick way to do a matrix of a 2x2. Okay, so what was that matrix again? It was 2, negative 5, 3, negative 6. Now this is the only time you can do it is with a 2x2. Okay, and how you do it is this. Here's what matrix I have right now. A, B, C, D. Okay, in a matrix 2x2, that's great. Any matrix, right? Does that make sense? Its inverse, we'll call this matrix A. Its inverse, so A's inverse would be this. 1 over AD minus BC times by, oh, it's been a while. I think it's D. I'm going to see if I'm right. Don't kind of write it quite yet. I think I'm right. I hope I'm right. I think it's that. Oh, I'm going to get it right. I really feel I'm going to get it right. Memory has served me for 5 years, people. I remember it. Okay, so if I ever had a 2x2, this is the method I would do. It's a lot simpler than doing it the identity matrix that I already showed. Okay, so let's go ahead and do so. So in our case, here's our A, B, C, D. So let's first find this. This is called its discriminant. Okay, so that is 2 times negative 6, which is negative 12, minus 3 times negative 5, which is negative 15. And then let's switch them up. So therefore, the negative 6 comes up here. The 2 comes down here, and then you just do the opposites. Anybody have questions on where I'm at right now? I switched A and D and did the opposites on C and B. Then this right here is a plus. So I'm at 1 over 3 negative 6, 5, negative 3, and 2. Then notice that's just a scalar, so I'm going to multiply it in. What's a third of negative 6? Negative 2. A third of 5? 5 thirds. A third of negative 3? Negative 1. A third of 2? 2 thirds. Is that the same inverse that I had before? It is, isn't it? Yes, yes. I could look back. Anybody saying yes with me? It is? Thank you. Okay. Obviously, do you guys think that was a lot quicker than doing attaching it to the identity and doing reduced row echelon form? Yes. Now remember, that can only be done on a 2x2. Okay? It cannot be done on any other way. It has to be a 2x2. Okay? Really, our goal today is finding inverses and using those inverses to solve equations. Okay? We can do one more example. Let's say, I'm going to get an equation here. 1x minus 2y minus 4z equals 7. 2x minus 3y minus 6z equals 5. Negative 3x plus 6y plus 15z equals 0. Okay. So our first thing that we're going to do is set up our matrix equation. So with our matrix equation, here's what I would have. 1, negative 2, negative 4. 2, negative 3, negative 6. Negative 3, 6, 15. X, Y, Z. Equals 7, 5, 0. Excuse me. So what I want to do is, once again, I'm going to call this matrix A, matrix B, and matrix C. So for me to find X, Y, and Z, I need to times matrix A's inverse to both sides, correct? Is everybody with me on that? So I'm going to times matrix A's inverse to both sides. Now, do you know what that is? I don't know what that is yet, so we're going to go find it. Okay? So how do we go find it? Well, I'm going to go on to the next one. Can somebody read me matrix A as soon as I get on the next page, please? 1, negative 2, negative 4. Next row. And what am I going to do to this? I'm going to attach it to the identity matrix. So that's 1, 0, 0, 0, 1, 0, 0, 0, 1. This is how you will do so, is you will attach it to its identity matrix, and then you will go through and make the left side look like reduced row echelon form. Or if you also recall, it's called Gaussian Jordan. Okay? So our first goal is we want a 1 right there. We got it. Nice, huh? I'm going to speed up this process, and I'm going to do getting this row to be a 0 and this row to be a 0 where that 2 and 3 are in one step. Is that okay for everybody? So the first thing I'm going to do is multiply row 1 by -2. So that's -2, 4, 8, -2, 0, 0. I'm going to multiply row 1 by 3. And when I get that, I get 3, -6. What am I multiplying that by again? 3. -12, 0, 0. Excuse me. That was horrible. And sometimes this is why I shouldn't do this. 1 times negative by 3 is 3, and this is 0. So I'm going to keep row 1, 1, -2, -4, 1, 0, 0. I'm going to add row 2 and -2 times row 1 together. -2 plus 2 is 0. 4 minus 3 is 1. 8 minus 6 is 2. 2 plus 0 is negative 2 plus 0 is -2. 0 plus 1 is 1. 0 plus 0 is 0. Anybody questioning how I have my new row 2? Once again, I don't believe the math is very hard. It is a tedious process, though. Take some time and some patience and some paper, right? All the 3 P's. Get that done. Then, new row 3, I'm going to go ahead and go old row 3 times row, and add it to 3 times row 1. So I get 0. Oh, look how nice this one is. It already gave us a 0 where we want. And a 3. 0 plus 3 is 3. 0 plus 0 is 0. 1 plus 0 is 1. That was actually a really good. Are all of them going to be that nice for you, though? Definitely, definitely not. Yes. I did not, because the reason why I did not times by -3, because he was already a 1 and this guy's a -3. So therefore I times the bottom row by 3. I mean the top row by 3. Are you okay with me? All right, guys, tell me what's my next step. Where that 3 is on the bottom right of our first matrix, we want that to become a 1. How do I become that 3 into a 1? Divide by 3. Is everybody in agreement? All right. So I get 1, -2, -4, 1, 0, 0, 0, 1, 2, -2, 1, 0, 0, 0, 1, 1, 0, a third. Yes, we okay? All right. Greg Hook, what's our next step, brother? What do you want to do? No, you're good. Where that 2 is above this 1, so this 2 right here, we want him to become a 1. How do we do so? We're going to go ahead and multiply what? Row 3. Row 3. We want to add row 3 because remember we want to work down here, and then up. So if I'm ever losing anything off the third column, I'm going to use row 3. If I'm losing anything off the second column, I'm using row 2. If I'm losing anything off the first column, I'm using row 1. Does that make sense to everybody? So I'm going to multiply row 3 by -2. So that's 0, 0, -2, -2, 0, -2/3. Everybody good with me on that? So I have 1, -2, 4, 1, 0, 0. Then I have 0 plus 0, which is 0. 1 plus 0 is 1. 2 minus 2 is 0, which we wanted, correct? Negative 2 plus 2 is negative 4. 1 plus 0 is 1. 0 minus 2/3 is negative 2/3. Yep, on top. Thank you. I had to think about what you were saying first. Thank you for not making me have a mistake, and which takes longer to find those things after. Okay, we're getting there. We have 2 more steps. What's our next 2 steps? So where that negative 4 is, I want him to become a 0, right? Which row will I use to make him get a 0? I will still use row 3. So therefore, I'm going to multiply row 3 by 4. So I get 0, 0, 4, 4, 0, 4/3. Feel good so far? Here we go. 1 plus 0 is 1. Negative 2 plus 0 is negative 2. Negative 4 plus 4 is 0, which was what we wanted. 1 plus 4 is 5. 0 plus 0 is 0. 0 plus 4/3 is 4/3. Then I should just have my other matrices, other rows. They shouldn't change. Okay, what's our last step? Wanting where that negative 2 is, we would like that to be a 0, correct? So I'm going to be multiplying row 2 this time because I'm looking to get rid of something in the second column. So therefore, I'm going to use row 2. So I'm going to multiply row 2 by 2. So I get 0, 2, 0, negative 8, 2, negative 4/3. Okay, here we go. So 1 plus 0 is 1. Negative 2 plus 2 is 0. 0 plus 0 is 0. 5 minus 8 is negative 3. 0 plus 2 is 2. 4/3 minus 4/3 is 0. Then I have just my other 2 rows. So right there, we called this side matrix A at the beginning, didn't we? Wasn't that correct? So therefore, this would be A's inverse right here. Okay? Any questions so far? So what I'm going to do, I'm going to take that inverse, if somebody will read it to me when I get back to my other page. So right here, remember this is where I was going to times by A's inverse, right? To both sides, correct? Yes? So I'm already not going to write it down, but A's inverse times A just leaves me this matrix B. You guys agree with that? If I have A times A inverse, they will always get rid of each other. That's the whole goal of inverses. Okay? So over on this side, I'm left with just X, Y, Z. Now what we have over here is A's inverse times C. Okay? Who was A's inverse? What did we get? We got negative 3. Was it 2? 0. Remember that. Then it was negative 4. 1. Negative 2/3. 1, 0, and 1/3. Okay, so that's A's inverse. And C was 750, right? First off, can I multiply A's inverse by C? Is it possible? I have a 3 by 3 and a 3 by 1. So is it possible? Because the innermost are the same, so therefore I can do so. So I'm going to take the first row, -3, 2, and 0, and multiply it by 750. So I have -3 times 7 is -21. 2 times 5 is 10. 0 times 0 is 0. So therefore, row 1, column 1 is -11. Now I'm going to take row 2. -4 times 7 is -28. 1 times 5, oops, what just happened there? 5. -2/3 times 0 is 0. So that ends up being -23. 1 times 7 is 7. 0 times 5 is 0. 1/3 times 0 is 0. So that is 7. So therefore, ladies and gentlemen, X, Y, Z is equal to -11, -23, 7. So therefore, I know what X, Y, and Z is. Yes, sir. Yes, you can. You could go back and plug it in. Let's go plug it in. Just remember those numbers for me. So the first X was -11, correct? So I have -11. What was Y again? -23. So -2 times -23 would be +46. And this was 0. Nope. What was Y? 7, right? So this is -28. So I have, that would be 35 minus 28. It is 7. So it does check out. Okay. My question is, does every matrix, are you okay, Greg, with that? All right. Does every matrix have a inverse? What if it was a 2 by 3? What's the inverse of a 2 by 3? Well, what do I attach it to? I have to attach it, or remember, inverses always only come in, the identities only come in square matrices, right? Does that make sense? So there's no way to always find the inverse. It only is, you can only have an inverse of a square matrix. Okay, because the only thing that comes back from an identity is from square matrices. So understand that not every matrix has an identity. Okay. What about if, like, for example, remember when we were solving and we had those no solutions or infinite solution matrices? They're not also going to have an identity, because it doesn't make sense to have an identity when they're like two of the lines are the exact same plane. Does that make sense? There's no way to do so. Okay. You guys want me to do another? One more? All right, let's do another. All right. Now this one, we're going to go rogue. I've been doing pretty good. You know, we did it just the same, but sometimes it's nice to know. Let's see. Okay, here we go. I'm just going to start right into the matrix equation, if that's okay with you guys, so I don't have to write the equation at the beginning. And this one might not be fun, so I just want you to be aware. Okay. So once again, we're going to go ahead and find matrix A's inverse. Okay? Matrix A's inverse. Whew. Here we go. Now, the key thing here, ladies and gentlemen, is that you must set it up the way that the equations are. And the reason why we have to do so is for the fact of the matter is that is the matrix, right? Now, when I solve it, I can move matrices around as long as I keep the row of the inverse with it. Does that make sense? So as we look at this, are any of them a nice 1 at the beginning? So we're going to have to divide by 3, aren't we? But is there any other rows that are going to be a little bit nicer if we divide by 3 or 2 or 5? None of them are really prettier than another, are they? So should we just go with the first one? Okay, so we're going to take row 1. Notice, guys, there's 9 steps to this. That's what reduced row echelon form is a 9-step process, isn't it? Okay, so we're going to make this a 1. So that's 1, 4/3, negative 1/3, 1/3, 0, 0. Anybody have a question on how I have what I have? Next step, what are we going to do? We want a 0 where that 2 is and a 0 where that 5 is. Can I do multiple steps in one? Is that okay with you guys? So I'm going to times row 1 by negative 2. Row 1 by negative 2. So that would be negative 2, negative 8/3, 2/3, negative 2/3, 0, 0. I'm going to multiply row 1 by negative 5. Hold on. Sorry. Hello. How are you? Good. You? I will. Can I give you a call back? I'm just in the middle of a class right now. No, you're great. All right. Go. All right. Thank you so much. Yeah. Bye. Awesome. Okay. So negative 5. So I have negative 5, negative 20/3 times him by negative 5. That's 5/3. Times him by negative 5, that's negative 5/3, 0, 0. Okay, so we're going to keep the top row. Notice you guys are seeing how fun this is with all those lovely fractions. And like I said, that's usually what happens. You'll get a lot of fractions. Okay, our new row 2. Negative 2 plus 2. 0. Negative 8/3 minus 3. That's negative 9/3, is it not? You guys agree with that? Why it's negative 9/3? Because I need to get a common denominator. And remember, 3's over 1, so I times 3 top and bottom, because negative 9 divided by 3 is still 3, negative 3, right? And the reason why I'm doing so is because it's negative 8/3 minus 9/3. So that's negative 17/3. Sorry about that. Negative 2/3 plus 1. Remember, 1's 3/3. So 2/3 plus 3/3 is 5/3. Negative 2/3 plus 0 is negative 2/3. 0, 0, or excuse me, 1. I forgot my 1 right there. Okay, now the bottom. Negative 5 plus negative 5 is 0. Negative 2, which is the same thing as negative 6/3. So that comes out to be negative 26/3. As you can see, not the funnest time, right? We can do it. This is 6/3 plus 5/3 is 11/3. 0 minus 5/3 is negative 5/3. 0, 1. Any questions on what I have here so far? Okay, where that negative 17/3 is, what do I want it to be? I want it to be a 1. How do I ever make anything 1? I divide by that number or I times by its reciprocal, correct? So the top stays the same. Okay, now I'm going to times everything by negative 3/17. So that's still 0. That becomes 1. So let's do negative 3/17. So the 3's cancel out, so that's negative 5/17. Negative 3/17. So that right there becomes 2/17. Negative 3/17, 0. This is not a very fun one to pick, but it still is possible. We just got to persevere. My finger, I swear, is getting a cramp in it. Yes. No problem. Okay. How did I get the result? So I had 5/3, and I'm timesing by negative 3/17. So what I did is those 3's canceled out. Hence the negative 1 times 5 is negative 5, and then 17 on the bottom. Yes, ma'am. Nope. I just took row 2 and I times it by its reciprocal, which its reciprocal is, if we look here, what's the reciprocal of negative 17 over 3? Negative 3/17. So I times everything in that column by negative 3/17. Okay? Yes, Skylar. Like, you probably have like 10 or 12. Not very many. No. And most of them, like some of the solvings, like you're only going to have 2 that are going to be 3x3s. The other 2 are 2x2s, which I showed you how to do the inverse really quickly, right? So there are some other inverses that you're going to have to find, but yeah. Okay. No. Okay, say that one more time. I get what you do that. When you do that, though, it eliminates this element, which is what you're maybe thinking. Because if I multiply row 1 by negative 5, it doesn't, because what's negative 5 plus 0? It kind of puts us back a spot. That's why to ever use this, we want a 1, we always have to divide. Okay, because if not, then notice what's 1 plus 0. And then it'll change that, and then I'll have to get that back to a 0 again, so then it comes right back. Does that make sense what I'm saying? Okay. Good question. Does everybody understand his question? He asked, why didn't I add some rows together to eliminate? It's because it'll come right back, because that 1 plus 0 is always going to be there. And that's the goal of that. Okay, what's our goal here? I think this one, as I just read, this one says use your calculator, so that's why it's probably not very pretty. I'm a mean SOG. Okay, but how would we get rid of this negative 26 thirds? What would we be timesing that second row by? 26 over 3, huh? I don't think you're going to get this nasty. If you do, I am so sorry. And you guys can all whip me with rocks or stone me as long as I get to wear a helmet. You guys want me to keep going? That one wasn't very fun. Should we do another 2 by 2 just to remember how to find an inverse of a 2 by 2? Okay, inverse of a 2 by 2. Seven halves, 2, negative 3/5. Oops, that's a half, sorry. If you finish it, I'll show you what it is. You guys want to see what it is? Here we go. We're going to see what it is. We'll use the machine, though. What time do we get out of here on a Monday? I always forget the times. But the sad part is, guys, if we taught this back in the day when I had pre-calculus, this would actually, we would do a lot of this via our calculator. So here is our matrix. Our matrix menu. I'm going to go over to edit. It is a 3 by 3. Okay, here we go. 3, 4, negative 1, 2, negative 3, 1, 5, negative 2, and 2. Is that what it was? So what I'd do on my calculator, I'd go second matrix, that, and then I'd do its inverse button. And look how lovely that is. Watch if I hit math fraction. Look at those fun numbers. That would be its inverse if I went through it. So I don't know. See, I mean, it's not very joyous times when you're playing with the fractions. Does that make sense to everybody, though? Yes, no? Okay. Really quickly with the 2 by 2, hurry and finishing one of those off. We're going to do it by using its discriminant. So remember, we switch these two rows. So this becomes negative 1. This becomes 7 halves. Switch the signs. This guy's 3 halves. This guy becomes negative 2. Now we times that by 1 over negative 7 halves minus 6 halves. And then you just distribute that through. My clock is off really bad up there. Okay, on your homework, you guys are going to do 10-5. Let's go 3 through 31 odd. And then 39 and 47. That's 12 problems. I think we can do that. If you guys want to see this other one really quickly, you just times him through. Finish off. So I would get 2/13, -3/13, 4/13, -14/26. That would be its inverse.